afternoon, we have talked about AI, digital test for COVID, and how 5G will drive the industry. Now we have come to another very hot topic, which is smart mobility. Our last but not least speaker for today's section, Vincent Wong, Director of R&D of Continental Automotive Singapore, will take us a ride on the cases, challenges in the mobility transformation, and discuss the growing importance of collaboration within the semiconductor industry. So over to you, Vincent. Thank you.
Hi, thanks, Glenn. Can you hear me?
Yes, loud and clear.
All right. So thanks for the very nice introduction. And also thank you to SSIA for inviting Continental to this prestige talk. All right. So today, a very good afternoon also to the friends and partners from this industry. Yeah. So for those who has known Continental as a rubber tire company, you must be wondering, what am I doing here in a semiconductor event like this? Well, I would say stay tuned for the next 20 minutes and you'll find out more. Yeah. So for this afternoon, I'm going to split my presentation into three sessions, three parts. First, I give a short insight about Continental, the business, for those who doesn't know us. Number two, I think what is very interesting for us all is the mobility transformation and the trends that is changing this automotive industry. And of course, what is it in for the semiconductor industries, the expectations, the requirements that the semiconductor industries can take part in this transformation. All right. So without further ado, let me move into a little bit overview about Continental as a company. So Continental is a German multinational. We are operating in close to 590 locations around the globe, and we serve all major automotive markets. Yeah. So 40% of our sales actually coming from tires and technical rubber. So for those who drive, this is where the tires, Conti tires comes. But 60% of our sales is actually coming from electronics and software. So what do we do? So think about sensors that warn you on your blind spot, the displays and the touch controllers on your dashboards. So Continental provides such kind of components to the car manufacturers. Yeah? Let me delve a little bit more into what is more relevant for us on this automotive technology, the box on the left. So looking a little bit inwards into automotive technology, you can see we organize ourselves into two big core business areas. One on the left would be autonomous mobility and safety. This is where the ADAS components, the safety advanced sensorics comes from. On the right, connectivity, networking, human-machine interface. So this is where components that connects the cars, the vehicles to the internet, intranets comes in. In the middle, we have this department called Holistic Engineering and Technology, HEAT in short, which is responsible for innovations. Yeah? So, and this is where the department where I come from. So Continental believes that innovation is a very important aspect for safeguarding the business for the future, and hence the ownership is in this department. All right, so this is a nutshell about what we do. And moving next, I will talk a little bit about our challenge for today. And I talk about urbanization. So we are all coming or living from the cities. Yeah. So more and more, we see challenges on the cities, and that is transformed into mobility challenges. So what are they? So let me highlight a few of them today. So number one, more people will move into the city year by year, yeah, for work. And what we will foresee, or from the UN statistics, is that in 10 years' time, there'll be close to 41 mega cities in the world. That's a large number. The number of trips that will be taken in an environment will also triple by 2050. What about cars? So today we have a lot of cars, but the problem is we only drive them from point A to point B, and then we park them in the garage. We don't use them because only 5% of the cars are in use all the time. 95% are stationary. It's not a good status. So imagine with all these urbanizations and the way we move in the cities and how we move around, it will drop a big challenge in terms of emissions, in terms of infrastructures, the load on the cities. So the cities will not be able to contain all these challenges, yeah? If we don't find a smart solutions together, right? So this is the problem. Now, here let me share with you a picture of a city in 2030 plus. I call it the future perspective 2030 plus. So this picture is where Continental used it to understand, to look at the future directions, and from there derive our strategies, our business opportunities. And sharing these pictures today, I hope that the community here will also be able to join this journey in this transformation. All right. So let's draw a little bit deeper into this future perspective 2030. There are 5 mega trends, and the earlier speakers, yeah, from Alan, from Glenn, actually they spoke quite a bit about them already. Yeah. So automated driving, cloud services, IoTs, software for the car. So these are all the mega trends that will actually be transforming the way we move, right? So to illustrate further on these mega trends, I will utilize 3 case studies to delve deeper into technologies. So what are they? So today I will talk more about automated driving. I'll talk more about smart city robotics and connectivity. So let's have a look at automated driving. All right. So in this chart, what you can see here is the market size. The market size for different levels of autonomy. Yeah. So the chart, the first bar on the left is where you can see in 2020, where most of the cars are still at a low level of autonomous driving. Yeah. In 2030, you can see that autonomous driving, especially the level 2 plus, yeah, will come into reality. So what we have today are vehicles that is already able to access the drivers in difficult parking conditions, able to warn the drivers when he or she is driving out of lane. Adaptive cruise control. So these are really features that we as drivers or passengers can already enjoy, right? And we can see that such solutions would continue to be in high demand in the next 5 years. From the 5 to 10 years perspective, this is where the AD level 4 and 5 will come into play. What does that mean? Driverless, yeah, driverless technology, where actually all of us will become passengers. So the driver is no longer needed. He or she will give control to the vehicles. Let me share with you a little bit more about this level 4 and level 5 autonomous driving technology, which I myself is very passionate about. So you can see here a kind of roadmap, what is happening today. In today, especially in the context of Singapore, there are already trials ongoing in terms of shuttles, vehicles, which is able to move autonomously in a small defined area like One North, like C-Trans, Sentosas, and of course we also have our homegrown TR68 standards to guide the deployment. Over the years, what you'll be able to see would be more and more of such trials being put onto the public roads, of course, in a well-controlled environment where the vehicles are staying the fixed path, there be geofence in a certain areas. Speed, of course, would be very slow to medium. Yeah. But the big transformation will happen around 2030, where it becomes a reality. The technologies, the sensors technology, the AI algorithms will be matured enough that we can enjoy really level 4 and 5 technologies for convenience. let's have a look at what is driving or enabling these autonomous driving technologies. So you can see that there are different components that are the eyes for the vehicles. So examples, camera solutions, LiDAR, radars, and driving control unit, so computers, and of course, all these communications, 5Gs. So they're helping the vehicles to make a sense of the environment, right? So this is a case where I can urge the industries that to take part in this transformation in terms of sensorics and electronics. All right. With that, I move into a second use case. This second use case, I call it the smart city robotics. So I'm going to share with you a 1-minute video. And in this video, it demonstrates a vision where a mobile robot delivers food to us. So please enjoy this video. All right, so hope you enjoyed this video. It's a vision of ours where food can be delivered by a smart robot. So you must be wondering, what is behind this video, or what is behind this robot? Yeah. So here you can nutshell, you can see it's very similar to its big brother, the self-driving car. So it talks about sensors, the LiDARs, the depth cameras, the radars, and of course, again, connectivity comes in. So again, smart sensors and computers are used to steer and guide such kind of mobile robots. Yeah. The main difference between this product and the self-driving cars is, of course, the components. The components should be small, should be light, and consume as less power as possible. And hopefully the price is also competitive. All right. The last case study I will share today is actually V2X, or connectivity. So in order for the vehicles and the robots to really make good sense of its environment, connectivity is the key. Yeah, and for connectivity, in the words of automotive, we talk about vehicle to everything communication. Yeah, so this is fundamentals. And of course, the technology behind is actually this cellular V2X, which is a 5G. So with connectivity, what will enable the vehicles or the robots to do is to be able to sense, for example, you can see the picture of a very busy traffic junction. Yeah? So the blind spots, the cyclists, the pedestrians, where in the busy junction might not be able to sense by the sensors, can be shared to the vehicles, yeah, by cameras on the junctions. The other example would be to move very heavy data-dependent information like 3D maps into the cloud. Yeah. So these are different use cases where the automotive industry is using connectivity to guide and to move the vehicles in the safest way. All right. So moving from the big picture, let me zoom in a little bit into what is going on within a vehicle. So here you can see a picture of a vehicle and what is inside it. Yeah. So today we have vehicles with many, many small, we call it electronic control units, ECU in short. Yeah. So every ECU is doing its own specific calculations. Yeah. Be it for the speed, be it for the position, so many small ECUs. The trend now is that to integrate all these small ECUs into zones, zone control units. So this is where the zone control units, where it's actually centralized. And these zone control units are then connected to a few of these large central computers, what we call high performance computer. Yeah. So in a typical vehicle, you have the body HPCs, you have the dashboard HPCs. So these different HPCs would be the masters to carry out all the calculations and algorithms for vehicle. Yeah. And of course, in a typical HPCs, we talk about over 2 million lines of codes. Yeah. Okay, what is in the HPCs? So since here we have the partners and friends from the Semicon, so I look a little bit into the microprocessors. So a typical high performance computers, yeah, will have the following requirements. Of course, scalable multi-cores. So this is used for processing real-time informations that for startup routines. And it also has performance core for processing decisions-making algorithm, right? Memories. So the memories will move from like 2 gigabytes to even up to 8 or higher memories. Communications, Ethernet, getting more and more important because of transfer of graphics, videos within the car, and of course, FOTA, over-the-air updates. So we also need all these Ethernet connections. Typically, in one of these supercomputers, we will actually do various partitioning to operate different systems, Linux, Androids, using virtual machines. So this is also another requirements. And heat, yeah, heat is again another big parameters that the industries needs to optimize. Okay. For those who are very familiar with the consumer industries, the demand on microcontrollers, what I have presented to you earlier might not look very fanciful, yeah, because the performance of the automotive world is not really that high. Yes, you're right on the perspective. But then we also look at other things. So on this picture, you can see here, due to the very harsh operating environment of a vehicle, so we have some other expectations. The high operating temperature that can reach up to 120, 150 degrees Celsius, the robustness for ESD, the long lifetime, more than 10, 15 years of operations, the low failure rate, the PPM levels, and now more and more, the cybersecurity compliance, yeah, that the standards are coming up. So these are the add-on requests or requirement that comes from the automotive industry in general. Right. So to summarize, I would say that the key trends in mobility are autonomous driving, mobile robots, connectivities, high performance computer. So this whole transformation to me is a very interesting period now, because now we are right in the middle of a transformation. And actually it's a good opportunities for companies globally and locally to come together to innovate, to collaborate, and come up with a smart city mobility solutions. Yeah. So here I would like to leave with words of collaborations, partnerships that for Continental Singapore, we are located in Boon Keng. So altogether, we are close to 1,000 engineers, developers doing R&D. So we are very happy to work with the industries, the semiconductor industries, to look for smart solutions together. Yeah. So together, let's drive towards smart mobility. And I hope that you enjoy and learn something from my talk today.
Thank you, Vincent.
Thank you very much.
Thank you. So now let us see what questions we have here from Johan from Swatchlock. Can you talk about talk more about the type of R&D that is done by your team in Singapore and comment on the R&D climate here in Singapore?
Okay, sure. So nice question. So first of all, what we do in Singapore, our R&D, we can say split into two parts. One would be for application R&D. So for example, just I showed pictures of sensors, ECUs that actually will go into consumers' cars in 2-3 years. So our team here will actually work on requirements that comes from manufacturers, and then we design the hardware, design the softwares, and then we test it. We even have test laboratories to subject the components to the test standards. Yeah? And of course, finally, we'll produce it in our factories. So this is one part of the R&D that we do. The second part of it, we also invest in platforms. Yeah, so many of all these computers or systems, we try to reuse them. So we have teams working together, of course, also with component suppliers to standardize reusabilities in platforms. And these platforms R&D would then be used by the whole of Continental. All right. So this is what we do for R&D locally. To the question on the climate of R&D, I would say that it's still a very vibrant environment until today. We are still looking to find talents in the industries. It's never enough, especially for software, for system engineers to join this industry.
That's good. And the next question, what is the progression towards establishing the safety standards for autonomous vehicles and robots, especially for embedded control systems?
Yeah, so I will say it's coming slowly. So as I mentioned earlier in my presentation, Singapore has already launched this TR68. It's a technical reference, especially for autonomous driving. Yeah. So it's not a real standard at the moment, but it already guides the industry that plans to deploy autonomous vehicles on the roads here. So it talks about security, it talks about safety functionalities, and of course, for R&Ds, companies like us, so we have to respect and take this reference into consideration. I will foresee that over the next 2-3 years, more and more of such kind of reference and standards would be coming into industries. I hope it can also be harmonized, because the moment there are different set of standards be deployed. So the kind of converging of standards will also be helpful for the industries.
Okay. The next question from Techming from CEI. How do you think COVID-19 will affect the urbanization trend?
Very, very interesting questions. So I would say it's a pulse, yeah, because I think people will still move to cities because this is where the work takes place, yeah. But the working style would actually change. The way we also move will also change, yeah. So for example, we'll stay more working from home. We might transfer less towards the office in a certain duration, or we also would maybe expect a more safer journey, yeah, that we are protected. So on one hand, it reduces the burden for transportation or mobility on the city itself, but it also throws out very interesting opportunities where we try to make journeys safe, yeah, for the user.
Okay, so Jeffrey from AEM, he congratulates and say, great to see Continental joining the SSIA family. So how do you see the test demographic, especially for production test, changes to accommodate to the complexity of parts that we see in autonomous driving?
So first of all, thank you, Jeffrey. Production tests. Okay, let me try to answer this question. If you talk about the demand on the safety standards of a vehicle, I don't see it being changed at all. Yeah, because the autonomous vehicle, in a nutshell, is still a vehicle. So we still expect the same high safety standards as what we have with let's say, a manual vehicle. Yeah. But what has it on top comes now is the high amount of software. because a lot of software is now used to compute the decision-making process of the vehicle, whether to cross the road, to speed up, slow down. So the industry has to think about smart way and use cases to test software, you know. So now more and more we are investing, besides the hardware-related testing, the robustness testing, we are investing more and more into software testing. I will see this is a big trend that the industry will go into.
Okay, next question from Satya. What would be a component, HW or SW, that you may want to procure from startups? So it's about the collaboration and partnership.
I see. So I take it HW, SW, hardware and software.
Yeah, I think so.
Yes. So for sure, this autonomous driving or mobile robots, as I mentioned, throw a lot of challenge. Yeah, for example, in the mobile robots, it's a very, very small component. So we are actually looking for fast and nimble solutions. For example, that there's miniaturized sensors that are small yet powerful enough to do its work. Yeah. So these are one examples. Batteries examples. Yeah. So we're always on the lookout for solutions that is agile and small enough to go into all these driving machines.
Okay. Okay, due to the limit of time, we can answer two more questions. First one from Son. Any outlook towards fiber communication for intra-vehicle networking?
Fiber communication. So I'm not an expert in communications, I must declare. So for me, right now, the main link of communication for us is still the cellular, yeah, the 5G network. So I can't really comment on fiber.
Okay, no worries. So the next question is, wouldn't the market size for cars reduce as individual car owners would reduce? I think Rajan is addressing like the current pandemic situation, and the private car, actually the number is decreasing. So how's your view about this?
Yes. So if you ask me, the trend is there, yeah, because of the reduce in the needs to move. So the car demand ridership has actually decreased. Yeah, but on the other hand, interestingly, we can also say that the demand has also come back because people wants to be safe, right?
Yeah.
So that's also kind of like a different way to look at it, where people also prefer to travel in safety, in comfort. So I would say that the world has to find itself, together with technology, what is the most optimum way, yeah, to travel or to move in shared solutions.
Okay. So I think one last question from Vanessa. Do you work with semiconductor companies in your R&D in Singapore? How can Singapore support your company in the R&D collaboration locally?
Yes. So answer is yes. I think some of the partners are actually in this room. Yeah. So for example, like I showed those microcontrollers. So Conti doesn't build them; we buy them from the industry. So we work with many of these semicon companies. Of course, we co-develop, we co-design some of these specific controllers. And I'm looking forward that this community here, probably we should come together closer to look at finding smart solutions, yeah, for autonomous driving and smart cars.
Sure. May I also suggest that for those companies who are keen to collaborate with Continental, do connect with Vincent in the linking group. So I think from there, both of you can talk more and the companies can talk more, and to see how you can work from there, right?
Sure, looking forward.
Okay, thank you, Vincent.
Thank you.
Yeah, thank you. So ladies and gentlemen, I think that's all the presentations we have today.